Log on, tune in, find out. Another good idea from Cambridge.
So today we're very grateful, especially grateful in fact, to John Wood to come along, given that he's just arrived from Boston on the plane this morning at Heathrow. Fortunately arrived on time despite the weather, and so we're very grateful to him for coming straight on to the seminar after a short night on the plane. He's principal of the Faculty of Engineering at Imperial College in London. In fact, as of this academic year, just started in October in that position. And previously, for the previous 6 years, in fact, to that, was Chief Executive of the Council for the Central Laboratories of the Research Councils. And for that, he was on leave from Nottingham University, where he's also been Dean of Engineering. John, in fact, has strong links with Cambridge, did his PhD here, and was also a fellow, a junior research fellow at Churchill College way back as well. So has these very strong links over the years. And his topic today is ethical aspects of science policy. So thank you very much, John.
Well, thank you, Dennis. Yes, it was quite strange speaking in Boston or Cambridge, Massachusetts yesterday and coming here to Cambridge, UK to do the same on totally different things, but not quite actually, as I think I'll show you. The other thing too is when Dennis asked me to do this, I was a bit worried because I'm not a fundamental scientist. I'm much more of a practical engineering scientist, although my field is materials science, probably nearer to Colin Humphrey's area, although he was a physicist. But I was encouraged by the fact that, of course, it is the Faraday Institute, and Faraday was essentially an experimentalist, so I'm an experimentalist. And I'm going to take you through a whiz tour, as it were, of some of the issues which are relevant to the position I held before and are still relevant to what I do today. One of the things I ought to point out, and this is this chairmanship of the European Strategy for Forum for Research Infrastructure. I'm going to talk about the global issues and global policy, and that was what I was speaking on yesterday. I also chair JISC Research Committee. Now, I find most academics have never heard of JISC, but if I say JANET to you, the Joint Academic Network, that's run by this lot, and I run the chair of the research committee looking at some of the issues about the future of networking, digital repositories and institutional repositories, and data mining and all these sorts of things, and aspects of the semantic web. I'm also aware that many of you, some of you I'm told, are not necessarily scientists or engineers. Don't worry, I may occasionally slip into the jargon, but I'll try and keep it at a level which is highlighting some of the real issues as I see them. Well, first of all, I thought, why on earth do we invest in public science? I thought this was rather a good question to start off with, and none other than I thought, well, better start with Gordon Brown, who sees it. A number of key statements he made. This was just one I happened to pick up from the 10-year plan that the government had, which was published in 2004, and Next Steps published in 2006 when it killed off my research council. And I should say I was given 12 hours notice of that, which is quite an amazing thing to decide to restructure science in the UK and give the people running it 12 hours notice. But anyway, it's all linked with the global economy and the concept that you need to invest in high technology in order to be ahead, and then to turn it from invention into commercial opportunity. One of the things that we were pressed as Research Council chief executives is to demonstrate the benefits from a socio-economic point of view of the investments in fundamental science. And for those of you who have been involved in this, that is very, very difficult to do in the short term. You can do it in the long term, but I'm afraid Gordon is looking at a 5-year cycle, and that actually is quite a problem for us. The minister I reported to for most of my time was David Sainsbury. He's got the same message: investment in science and innovation is not an intellectual luxury for a developed country, but an economic and social necessity, a key part of any strategy for economic success. At this point I was getting a bit depressed reading these and thinking, what am I doing with investigative blue sky research? But I then actually came down to the very recently published presidency conclusions of the European Council, where they talk about promoting the knowledge triangle. And for those of you who worked within the European context, you've got to realise that there are certain jargon, Euro jargon you need. So knowledge triangle is one of them, which is about education research-led innovation. Again, it's talking about the development of knowledge-based economies, but also about the need to bring in highly qualified scientists and get the whole atmosphere, as it were, of innovation moving forward. And here's some more jargon. If you want to show you're really up in the EU, you talk about the Lisbon Agenda and the European Research Area. And it says in that document that they are delivering. Well, we wait and see. Okay, well, that was the sort of politician's view of why we get involved. This is my view, and I'm not going to come up with any definite conclusions today. I'm going to pose problems for you because I want you to try and get involved, as it were, in some of the debate. So, oops, I've gone too fast. So for almost 7 years, it's 6.5 years, so it's either 6 or 7, whichever way you look at it. I had a budget when I left of 300, oh, sorry, what have I done? It's on top. I had a budget when I left of 310 million. Do I press mute now?
I'm not sure what the buttons do, actually.
Trigger happy. I still keep going anyway. And the real question then is, yeah, no, it's this. That's the easy one, in fact. This is when I've got 100 slides, so I'm trying to remember what is that.
It's flashing, which I'm not quite sure what it means.
If I press music again.
No, it's Polly here, she knows what these buttons do.
Well, I'll keep talking
keep
anyway.
Talking for a moment.
Yeah.
Just see if it
So I had a budget of 310 million, which was one of the smaller budgets of research councils. And the question is, where do you spend it, how do you spend it, and what are some of the issues you have to look at, specifically in the divide in different areas. And then the question, most fundamental question is, why not build a hospital with that money rather than actually spend it on toys for the boys, as it were, in terms of investigating new phenomena. I come up with very much my reason for investing in blue sky research is that I think it's actually a mark of a cultured society. It's certainly a mark of my Christian faith that I believe that there's a wonderful world to be investigated, even if we can't make this one absolutely work. I'll go into another universe, very promptly go through some wormhole or other.
Yeah, just flashing, and our person who knows about it is not here.
Right. Well, I have got it on my machine if necessary. I have to try and remember what else. So, anyway, then that's, as it were, the Research Council's Chief Executive's view of why we invest. But then you've got the researchers' view, which is completely opposite to what the funders' view is, and also the people setting the policy's view is. And how do you reconcile that? Because, of course, the researcher thinks he or she has got a brilliant idea, can't understand why on earth anybody doesn't want to fund it, and certainly doesn't understand when a research grant gets... I've got an emergency help here. Oh, bless you.
It was on.
I pressed some button on here, which I wasn't meant to.
It did stop there, press it again. It's still flashing now for
Another minute. Anyway, I was going to say talk amongst yourselves, but I think there are some very big issues too, because as far as I'm concerned, the research that I see coming up is not neutral. There are upsides and downsides, and actually one looks at, say, nuclear energy. What is your attitude towards that? We've known for the last 7 years that the government was going to announce it was going into nuclear, and you could see the softening up process. I saw the energy white paper of 2004. The paragraph got taken out the night before it went to live because the government was concerned about I should be talking to this microphone. Sorry about that. Was concerned about the impact, but you could see the softening up process in the media, and eventually, of course, a few weeks ago they went live on it. At Imperial, we've had a program called CANOE, which stands for Keeping the Nuclear Option Open. Again, not another canoe. But so that's, we knew about this a long time ago, and the research councils all knew that we were steaming up for this. But nuclear energy has upsides and downsides. If you look at the well, I've got to do something else anyway.
It's coming.
It's coming. Thank you.
It should be coming. Yeah, just
it must
reboot. Yeah.
That's the betting I pressed the button again. What about stem cell research? And I guess with biologists here, I want to say, well, what about embryonic stem cell research? Now, the way I was looking at that was not from the ethics of whether you should use embryonic stem cells, but what the implications of using them were in terms of joining them onto photonic and electronic devices. We were doing some projects at the Rutherford lab where I was based on growing affixing these cells to pass electronic signals through. Initially, this was to overcome paralysis, that you could put these things in, and in fact we can grow them and leave them on. But also we were linked in with brain science. And you started to ask your questions, well, it would be rather nice to have a little maths chip popped into your brain and take it forward. But then, what about mental illness? And so this was the area we were starting to come from ethically. How far should we go in taking these things forward? Are there limits to what one should do? So rather than looking at the ethics of whether you should even use stem cells, we were looking at the applications of whether you should use them or not. And there's some really frightening conclusions. At the time, my minister was John Battle, who was a Roman Catholic, and I showed him the information that was coming up, and I said, that's an artificial brain, John. And he went white and said, what are we going to do about it? And okay, so we're a long way from the reality of that, but that's the sort of thing that comes up, that you have to look to the future. Then we're looking at, I better wait, because I've gone on about 4 slides from my memory at this stage. And there it is. really. It's a big file, actually. That's the problem with it. It was put together on in the lounge at Boston Airport. I shouldn't have said that. Actually, it was put together this morning. One of them. Anyway, I think what I'm trying to say is that for all the technologies and the engineering solutions, there are upsides and downsides. There's no question that if we want to have a quality of life as we have at the moment in terms of energy, we're going to have to invest in either nuclear or some other form which we don't know about. Also, we don't get very much indication from politicians about where they would really like research to be funded. And so it's very much left up to the research councils primarily, but also the academies, as we'll see if we ever get there, to take these things forward. And I would say, just talking earlier, the research councils are not very good at this. They don't know really how to engage at this level. Right. Do I have to? I think you've seen that slide before. Okay, thanks a lot. Okay. Don't go away. Well, I was trying to remember what was on this slide, but researchers' reasons is a thrill because they're thinking unthinkable. Some people even think they help society, defending national values for some and working with others. There's the deadly element of the RAE, which I think distorts research so much that it should have been binned years ago, but that's my personal opinion. But I don't think the REF, as it's called, which will take over, is any better. It looks absolutely awful. But I said at the end of the day, I think it's a mark of a cultured society to constantly strive for the unknown. I think too it ought to be fun. It's a word that you don't often hear now. But when you actually ask most researchers why they're doing it, it's often to do with peer group recognition. But I remember the first two. I couldn't remember security. And the work that's going on in security, as I'll show you in a little while, is really about making people feel safe, feel wanted, and all the rest of it. but Big Brother's watching you, and how much data do they hold on you? And this is going to be a theme I'm going to come back to, is who holds the data and what is truth in that respect. I'm encouraged too that engineers at last have woken up to the fact that ethics is a word that they can spell. And about 5 or 6 years ago, there was this report called The Engineer of the 21st Century. And it talked about engineering looking for solutions, looking for holistic, sustainable solutions, integrity and commitment to sustainable development. It all sounds very good. But I was really encouraged that the first #1 recommendation was individual engineers should understand their personal ethics and values and those of their employers if they are to recognise those of others and influence change. And then it goes on in recommendation 6 to say that the industry and also, I think there's another one somewhere, that the professional institutes should enhance this. And I'm glad to say the Royal Academy of Engineering now does have an ethics committee and an ethics board which look at these things. What it actually means is another matter, but the word at least is there, and I think you'll find more and more people are questioning what they're actually doing. But in the end, who decides? What is the legitimate area for science support? Well, it depends on which view you take, but for most UK researchers, it's probably this sort of list. Starting with Europe, we've got the Commission, run by the Parliament and the Council. More increasingly, the European Investment Bank is getting involved in big projects, and they are actually quite a powerful broker. We have organisations like the European Science Foundation, which is a bit of a waffle shop actually, but is quite influential. There's another group called Eurohawks. Has anybody ever heard of Eurohawks? European, yes, anybody's been involved in research councils, that's the heads of research councils. Then when you get to national activity, obviously government, but the civil servants, the boffins in Whitehall, obviously have a major impact. And then there are a whole waft of special advisors, charities, academies, research. So you can see actually it's not just one pinpoint where you can actually influence these things. And in the UK, as you know, where the funding is set by the Comprehensive Spending Review, which is on a 3-year cycle. The Framework Programme is a 7-year cycle in the EU, and the World Bank, it just takes projects one by one as well. So I didn't mention the World Bank, it's probably less of a player than the European Investment Bank. But there's a whole host of parties that have got their finger in the pie here. In terms of allocation, things get a little bit more focused. There's the Framework Programme, which is under the European Union, and I'm very glad to say Janusz Potownik is the commissioner there and is very effective in really focusing what FP7 is about. Very, very few MEPs and MPs care, and that is one of my biggest sadnesses. There's much more influence and thought in the House of Lords. Select committees are an absolute pain, but they do hold government to account on some of these things. A really important group actually is the Treasury Innovation Team, which actually do advise on where the allocations go. And then we're back to some of the other groups down here which we've already mentioned. Okay, so some of the areas to reflect on which are hot, as it were. I've already talked about nuclear energy, animal research, with Dennis here, I'm sure he's got views on that. Defence, stem cells, climate change, terrorism, population control, personal information, and then some softer issues but very important: sustainable environment, security, supply of water, which is one of the big issues before us, and why on earth do we want to be involved in manned space travel? But these are all the issues at the moment which are on people's minds. An all-time bestseller that came out in December is the book that we all waited for, from Dios, as it's now called, which is Where the Money Is Going to Go. And this is eagerly snapped up by researchers, well, at least those funding researchers. I'm sure most researchers never even looked at this thing. But my team at Imperial, I have a strategy team that delve right into this and actually try and work out where we should be. I shouldn't give you secrets about how we go about things, but it's really quite important that you look at it. And in that document, you see where the highlights of the allocations are going to be. And you pick up from that that number 1 is energy, not surprisingly, carbon-free cars. Number 2 is environment, not surprising. Number 3, I think, is security, again, not surprising. Number 4 is the fact that we're all living longer and how are we going to get ourselves ready to keep going until we're 90, 110 or whatever, and still have a quality of life. None of these are surprising, but then we get down to the more nitty-gritty about the digital economy and what that really means for us. Nanoscience has to be in everything these days. It just, as far as even when I was doing my PhD here, I now realise I was a nanoscientist, but I didn't know it. But much more in terms of what we can get from nanoscience, the idea of manipulating molecules and atoms to actually deliver what you want. And this you can't read, and I tried to make it clear, but I couldn't get it right. These are the allocations to the different research councils. And what you need to look at is the numbers. Where are we? Yes, you need to look at, these are the different years of the spending review period. So this is 08, 9, 9, 10, 10, 11. And you end up with a figure of about £3.5 billion a year in 2010-11. That's a lot of money to spend, and how you decide on how you do it. Then there's some money goes to the Royal Society and the Royal Academies down here. Then quite a lot of money, which is my interest in the past, goes into large capital projects, rising from about 100 million to 250 million over the 3-year period. And then there's some treasury speak down here, which none of us ever understood, but it's amazing. Now this was hailed as a massive increase in funding. Well, it is an increase in funding, but it's a decrease in the amount of research you can do with it. But that wasn't highlighted, and we all knew that that was going to be the real problem. The money would go up, but the volume will go down, and that's now having an impact on how these things are being forward. Well, we're not the only country that do this. In the US, they have an even worse system, which is a yearly spend, and President George W. Bush makes these fantastic statements about the national priorities, future energy, security, we must trust in the creative genius of American researchers, da-da-da. And so he asked Congress to double federal support for critical basic research in the physical sciences and ensure that America remains the most dynamic nation on earth. Grand words said earlier this year, just last month. And one of the big areas is in energy research, and they want to spend over at least $100 million a year, which isn't very much actually, to really look at new areas of energy research. Marvellous. And they wanted to, they're a big player in ITER, the confined plasma fusion experiment for for power, which is being built in Cadarache in southern France. Marvellous, you know, the biggest country in the world putting its money where its mouth is. And you get down to the allocations, you look for all the money, these are all the numbers that went to the Office of Science, and my friend Ray Orbach, who's the man there who deals with it all, is really upbeat about it. And then there's a cut. And as the American said to me yesterday, he said, we've been zeroed out of the budget, and they cut all funding to ITER, the big fusion project, just out for the year. And they've been hit very, very badly, because all the words were fine, all the political rhetoric was fine, but there was a battle in Congress about something else, and they decided to take it out on the science program. So you can have all these great ideas, all the things that are right, but suddenly things like that, they come and hit you. So what are the upcoming issues? Globalization is one of the big ones. We are moving away much more from the individual researcher doing their own thing into terms of very large groups looking at big projects and big problems. And as I, oh, sorry, too fast. Oh, don't worry. We'll go back on. The other big area too is what's happening. Oh, sorry. Yeah, the impact of e-research. You ain't seen nothing yet, and as I'll show you later on, what I believe are some of the big ethical impacts of what's going on there. Politicians want solutions, and they're looking for whole body solutions. And there's more and more impact because of this in terms of the global research of large infrastructures, whether they're real, physical ones, or virtual ones. So these all link together. We really are moving to a new paradigm in the way research is done, and I believe that has big knock-on effects to the way we educate our scientists and engineers. And it's going to be quite a struggle to know how we balance the brilliant ideas of individuals with this sort of approach. Well, I promised the Lisbon agenda. I thought I'd better show you Barroso. probably going to be superseded by President Blair or somebody else in the future, so this figure will go there. But actually we are starting to see that the European Union is joining itself up at long last. And the European Research Area consultation green paper last year, we've got something like 10,000 replies, all very much focused on strengthening the interaction between the various member states and the Commission, so much more money going in there. Of course, the one country that always objects is the UK, which is always embarrassing for me, because I chair the group which does this, and that's this group here. And again, we had a conference just last year when, again, this whole area of governance of large research projects was coming to the fore. How do you know that these things are under control and who runs them? Because they're getting to the size now that nobody quite knows who's running them. Okay, so I'm going to look at a few examples, and the one I really want to concentrate on is the future of e-infrastructure, because it's all about trust. It's all about who do you trust and how do you know things are true. I'm going to talk about large European and global projects, again, because of the governance and the impact that that will have on the way we do research in the future. Because I'm chairman of the international committee looking after this facility, I am going to talk about the X-ray free electron laser in Germany, but don't worry if you don't know what it is. I've got lots of slides, but it's just a dirty grey X-ray source, and that'll be the most powerful in the world. Okay, e-infrastructure, what does it mean? Well, it normally means obviously putting the dark fibre in between laboratories, so it's essentially networks, but more and more it's how you actually manage the information that's being flowing around, and the concept of middleware and the concept of metadata, because the amount of data is so great now that you can't cope and handle with it. So who develops the interrogation software to actually interrogate this information? Who decides what data you ditch and what you keep, and how do you access it? And a lot of this is to do with high performance computing. More and more, though, it's getting towards content, and I also chair the JISC Scholarly Communications Group, where we're looking at linking of electronic publications with research data. Okay, now again, there are some very big issues here that come to the fore, as you'll see. So there have been various reports. The Office of Science and Innovation, we very reluctantly put out its views in a booklet last year. It seems very keen not to actually be prescriptive about this, but because of the issues, we've been forcing them more and more to take it on board. Essentially, research councils see their real issue there for them is that everything that is publicly funded should be publicly available. But they have different attitudes to the long-term commitment. The ESRC, for instance, insists that all data is filed in Essex, at the Essex files. The EPSRC, and we've been talking about that, have no concept about what you do with data. It's the university's problem to keep it indefinitely. Most vice chancellors don't realise how much that's going to cost. And then my own group is looking at some of these issues as well. MRC are probably ahead of it, but they say that, I think the fundamental statement, research data are publicly funded and as a public good must be available. And that to me is a great tenet of what research should be about. And again, they talk about the governance. So these are great statements, but actually how do you make it happen and what are the implications? The OECD jumped in as well. They came out with 13 principles. I won't go through them, but again, openness and access on equal terms, wherever you are in the world, whoever you may be. Oh, there's more. This is what the OSI recommendations were. Again, access, make easy discovery. But this is the thing here, confidence in the integrity, authenticity and quality of the services and resources they use. A recommendation, but no idea how to do it. What are the big issues? In terms of data deluge, you haven't seen anything yet, and I'll show you what's coming up. In terms of curation and provenance, at the Rutherford lab where I was, we had last year 50 million hits a day on our firewall. 50 million. I had to have 24-hour-a-day coverage, making sure people couldn't get through the 5 firewalls that we had. It's a massive problem. The data sets have to be interoperable. How do you actually integrate a data set on aging with social housing, for instance, and then indeed with some sort of genetic mapping as well that you might want to do, looking at different ethnic backgrounds. So interoperability, as I'll show you, is a very big issue. We're now moving towards much more multidisciplinarity of research, and as I said, linking publications to data. Marvellous thinking, this massive increase, but what are we coming up with? Are we just going to have a breakout, or are we really going to see nations speaking unto nations? Is it going to be a vehicle for peace or warfare? Okay, so what is the future? And one of the key questions is, how much supercomputing do we really need? How do we get the different disciplines to work together in terms of putting this information together? How do we actually stop computer scientists who are thinking way out there with the actual needs, aspirations, and possibilities need to be melded? I'll come, as I said, to the massive data sets. But I think this is the fundamental. How do you know something is true? How do you know something is true when there's so much there? And we need to have strong measures to track provenance. I write papers on what is truth in the digital age, and I'm actually quite frightened that we don't actually know. Those of us who had research students who used to put the reference, Pop, Roy, Sop, whatever it was, you know who Jones and Blogs was, you could actually interrogate them. You now just have a website, and of course nobody knows quite who has put that up necessarily and what its linkage is. So there's all sorts of junk going around. Okay, and again we're now talking about accessing techniques, data sets from all around the world and bringing them together. And users aren't actually experts and don't know how to interrogate the truth of these machines and also the data sets. Biologists, for instance, will be sending samples all around the world to facilities and remotely access the data and you'll be able to run it from your desk here in Cambridge, although the sample is being looked at Spring 8 in Himeji, for instance. This is my old lab, and this just shows you the scale of the problem. This was last year when we were opening Diamond, a new synchrotron, £256 million. My office was there. But down here we were opening the second target station for the neutron source. In here we had the world's two most powerful lasers. Here we had the largest space technology laboratory in Europe. And in here I had a whole bunch of particle physicists who I wasn't sure what they were doing, because they knew. And then we have people down here who made it all happen. And it's bringing all this lot together, because that was the critical thing. So for instance, somebody working, well, this is an example here, how we can put different amounts of data. So we have a street plan and an aerial view, you can put them together and you can find out where you were. But this is more the sort of thing, if we're looking at maybe a biological structure, bringing together neutron diffraction, X-ray diffraction, nuclear magnetic resonance, and they all come together. And it doesn't matter where these are being done, because they'll all be downloaded to you. But how do you know that hasn't been corrupted? Okay, this is this diagrammatic form of what we actually are doing. Okay, researchers are creating knowledge, that's fine. So they're creating it, they're storing it, and they want access to it. That's great, that's fine. Who's going to do it? So underneath, somebody's got to provide the services and the provenance and the governance of what happens. So that's what the researchers want to know. They don't want to know about anything else. They just want to get on what we call the virtual research environment now. But the rest of us have to worry about how we do this and how it's put together and what sort of infrastructure. And the researchers shouldn't have to worry about it, except they should have confidence in what it's all about. This is how it used to be, that you created raw data, you analysed it, you published it, and you went home. I used to do it here. I woke up in the morning, had an idea for an experiment, did it, sat down with my friend, we had a bottle of claret between the two desks, and by the second bottle of claret, the publication was out. It was very simple, and we sent it off to whatever the journal was. But actually what's happening now is that the data is coming from many sources, it's being converted in many different ways, there's a vast amount of data repositories that you're going to interrogate as part of your discussion, and they're going to be integrated publication. And so we're looking for this common infrastructure that brings all this lot together. Well, you know the web has changed everything, but in fact it's very difficult to keep pace with what's going on. I already mentioned this, that here many research communities have limited computing needs and aspirations, but they are being increasingly serviced by middleware, which actually does a lot of the work for them, and as I've already mentioned, data management and security. And we need to give access which is easy for the researchers, but to have confidence in what they're doing. Well, I think I'll move on here, but this is my own committee's group. Things are moving very fast. There's a group in Europe looking at this, my own group is looking at it, and I'll talk a little bit about Géant 2 in a moment. And the Americans have just produced a booklet on their national cyber infrastructure. I'll move on because we're going to run out of time. Okay, the group I was involved in was just over a year and a half ago launched a roadmap for the next 20 years of what's going to go on in Europe in terms of large research facilities. That's both virtual and physical. And brings together 27 member states, and I still remember 5 minutes to 6 on the 28th of September, I think it was. All 27 member states delegations voted unanimously for 35 projects that Europe were going to focus on. Unbelievable. I've never seen Europe vote unanimously before or since. We produced this roadmap, which came out, has been an all-time bestseller. It's used by everybody. The first to get their hands on it were the Chinese. They got it a day later, even before I'd given it to the Commission. How they got it, I don't know, but they got it, and the Japanese followed very shortly afterwards. And it covered all areas of research, not just physical sciences and engineering. So social sciences and humanities, there's a couple of projects here, but I think this first one illustrates some of the issues that are involved. This is called Clarin, and you don't need to know very much about it, but it's to do with what does a word mean? What does a word really mean? Okay, you can look it up in a dictionary and see what it means, but that doesn't help you too much because it will have changed during the centuries. It also changed when you go to the north of England to the south of England, possibly. More importantly, it'll change in the context in which it's used. And when I produced this roadmap, I had a slide that talked about transferable skills. And my friends in the Commission said, but John, we don't know how to translate this into Spanish and Italian. What does it really mean? We've looked it up and we know what it means, but it doesn't mean what you mean. And I said, well, it's in the context. Every UK researcher knows what it means because you have to put, it's obligatory to use that word in a research grant application. It's one of those words you just have to have. It doesn't matter what you do about it, but you've got to have it there. And I said, in the context of research application, now we know what it means. So this is actually looking for trust in language, not just a translation, but what does that word really mean? And I think this is a very exciting study that's just been funded. It's relatively cheap at 106 million, and it's already started. And I think this is one of the really exciting. But it does show you what these things can do, and where perhaps the Tower of Babel is not such a bad example after all, because this could all fall apart. Another one is in aging and environment, and again saying what is really going on. How can we actually help the people who are getting older? That's all of us. And what sort of retirement scenarios do we want? And at the same time, of course, is Big Brother looking in to see what you're actually doing and keeping an eye on you. So there's some big issues there. Environmental science is another area. I think I've just got a couple here. Here's one where all these little floats are being dropped in the sea. I think I've got how many thousand there are. All around the world, sending up information about the environment to satellites and then back down to computers, just showing what the monitoring, the effect we're having on sea surface situations. The one I wanted to show you, next one I think is this one, Life Watch. This is about biodiversity. I picked this slide up yesterday actually because the talk was on this, but again looking at how you bring various different areas of research together into a whole body problem. And basically you're getting the information from all these sensors all around the world. You're analysing the data, you're taking the data and then analysing it, and policy is coming from this. And so how do you take this information, how is it interpreted, is going to influence science policy at the end of the day. I think I'll just move on quickly here. This actually just shows, I think, that there are many labs involved, many services. There's a problem-solving environment. You're getting information from different agencies, and you're actually using organisations like the European Space Agency to give you validation of the data, but you're also using CERN to give you the validation of the e-infrastructure that's supporting all this. So what is a biodiversity project is actually involving 2 other agencies who are helping in this respect. Energy is a big one, obviously, but there was remarkably few ideas on how to solve the energy problem from a technological or infrastructure point of view. Sorry about this, this is part of a standard thing. The project that we in the UK are most interested in is HYPER, which is a massive bank of lasers focusing on about a cubic, or a quarter of a cubic micron of material. They've got to shoot 5 times a second. At the moment, the only experiment that's being run at the National Ignition Facility in the States, they do 1 shot every 4 hours. So it's a bit of a technological challenge. But this will demonstrate whether you can get nuclear fusion using lasers. And if it does work, this could be an alternative to the ITER approach. Biomedical and life sciences, a lot of virtual activity going on there. Biobanks, bringing them together, and also this project in looking at the relevant mouse models around Europe and bringing all that information together. I'll move on quickly. Just move. These are just different things. European large-scale telescope, the square kilometre array, which will probably be built in Australia or South Africa. These are all the future things, but you can see they're massive. And this is where it all crunches around the computing capability, about how much capacity you need, high throughput machines against capability. The problem with capacity build machines is that the energy now, I think at Daresbury, where we had the high performance computer, it was called, the amount of energy I had to use for air conditioning was 4 megawatts. And as it goes up in scale, it gets bigger and bigger. I'm convinced you have to place these things in Spitsbergen on the North Pole. It's going to creep and cool, because they really are. Whereas the high performance machines are much more energy efficient, but need a dedicated approach to taking things forward, and not so accessible. There are visions too for space, for particle physics that are there as well. I'm moving very fast, sorry about this, but we're going to run out of time. So the European Union is looking at how do you make all this lot work by bringing, obviously you're using dark fibre to share, you've got computing there, and then here we are sharing and federating scientific data, and then you get the solutions coming up, because they're all coming out of the same base. And, okay, so that's a slide we got yesterday. Around Europe, of course, we've got this thing called Géant, which is the grid that links this, and they link into the world's grid as well. So all these things become interoperable. So the global dimension in terms of how we take things forward is really important, how we get agreement. I actually believe now we need something like a Geneva Agreement on data store and data ethics, if you like. I will move on. Sorry about this. It's, my enthusiasm got the better of me when I was doing it. This is just the way we build up the computing structure. I won't spend time on that. Sorry. I'll just move on because it's just too much of this. Here, well, this is the one I really want, I think. Oh, wait with me. But again, it gets to the point now. These are where all the data is stored. How do you sustain it? How do you protect it? How do you make sure you can get at it? But more importantly, how do you trust it? How do you trust it? Okay, well, we're not the only ones looking at it in Europe. The ministers are now looking at it. It was the chief topic of the Carnegie meeting here in December in the UK. It's going to be the ministerial G8 meeting in Tokyo in June, and this is the #1 topic. How do you know? How do you store these data? How do you know it's true? I will move on. Sorry, this is just to show you that I do go to CERN. That's me there. This is the compact muon solenoid. Just to give you an indication of the scale of some of the detectors that are there. And the next one is the Atlas detector, and a person is about this height here. So these are, now the interesting thing here is that 99.9% of the data has to be taken out by the time the information has got from there to there. in about 2 microseconds. If you don't do that, then you swamp the World Wide Web in 10 seconds. And, well, I think they have every right to, since they started the World Wide Web, but who decides what data gets taken out? How do you do it? Okay, well, this just gives some indication of the sort of detectors that are used generally now. They're multi-dimensional detectors, but the thing that's killing us all is the speed of the electronics and the amount. And not only are you getting experiments that you can repeat with massive data sets, there are some experiments you can't repeat, and this has just happened to be one where taken from satellite. This is Etna exploding in Sicily. So you've got to be able to capture that and hold it, and you don't wipe that out with your metadata. This was the scale we were predicting, 20 petabytes of data. A petabyte of data, for your information, is a kilometre high of CDs. So that's 20 kilometres high per year coming out of that one lab, okay? And what do you do with it? But it gets worse. These are the various data stores that were there. Who do we trust? And the problem's going to grow. And I'm going to quickly whip around. This is the one that, sorry about this. This is a facility I'm involved in. It's the next generation of X-rays, which really will allow you to take atomic resolution pictures in real time. As I pointed out to Lord Sainsbury, synchrotrons take snapshots, this takes movies. Okay, it's an expensive movie. We've just got secured the funding for over €1 billion to build it. But there was a key issue there. Germany are putting 60% of the money in, Russia 25% of the money. And they're going to control how this thing works. Okay, well, the key here is that we can now see atoms moving in real time at atomic resolution. Forget about the rest of it. And here it says here, we can actually portray atomic resolution in 4 dimensions of space and time. And the big prize is potentially to look at how biological molecules interact between themselves at atomic resolution in real time. And there are other things in terms of material science and chemical processes. And this is one of the early experiments on the preliminary experiment at Flash that showed that you can actually get diffraction patterns at the millionth of a second time resolution. The trouble is you smash up the molecule at the same time. When I'm describing it to my wife, I said it's like being shot by your friend and you smile at them before you know you're dead, and actually we're getting the information out before the molecule breaks up. That's what it looks like at the moment, the prototype. It's about 800 meters long. The real one, which is the one that's the kit, is going to be 3.5 kilometers long outside of Hamburg. I'm trying to move on fast because the bit I want to show you, this is something, that's the model of what it might look like at the end. Is these detectors. Okay, then. Anyway, it's moving too fast. Why did it do? Yeah, these detectors now, just show it on this one here, are so sensitive that they can actually operate in that time resolution. And there's, I think it turns out, yes, that's right, they turn out 10 gigabytes per second of data. And that's the figure to get hold of. And they're one of many. And this is what they store at the moment. This is a way of storing 4 petabytes. It's not a big physical facility. But this is what the German lab estimates will be the amount of data coming out and stored in 2016. Remember, at the moment, at the Rutherford, we store 2. And it cost me 15 million a year to store 2. That is what one lab will be turning out in the near future. So it's not a technology problem. You can store it easily enough. But it's critical of who actually holds those data and ensures they're not corrupted. Now, just this morning, I picked up a paper which was sent to me from the chief librarian of the University of Alexandria. And in her paper, I didn't read it fully, I thought this was quite I just pasted this in. Upon this gifted age in its dark hour, falls from the sky a meteoric shower of facts. They lie unquestioned, uncombined. Wisdom enough to leech us of our ill is daily spun, but there exists no loom to weave it into fabric. So I thought that was quite a nice quote, so I found it in there to show you that librarians are equally wired. So, I only got there. Conclusion, complex situations require complex solutions, but who is really in control? I'm afraid technology is not going to wait for esoteric, philosophical or theological debate. So who do we trust to lead decisions? Are you going to trust politicians? Okay, and how do we trust internationally? How is the governance of research made transparent and open to account? Given that the Gulf states are now getting more and more into this, how much do you trust the people taking the decisions? What happens if a project is zeroed out of the fiscal budget in terms of international trust? The trust in America has bottomed because they pulled out of ITER. As I already pointed out, I don't think any technology is either good or is just good. There's a good side and a bad side to everything. Is the aim of international dialogue a good reason for taking these things forward? Who's going to police the big data sets? It is a wonderful world, and what are the limits to exploration? I don't know what they are. I've never put a limit on it myself. And as a Christian, I ask myself, why are faith communities so silent in the debate, looking at this? I've actually tried to raise this in the, I am a reader in the Church of England, and I sit on the Readers' Council. I've tried to raise it there, this sort of glazed look. Well, I suppose you know why now, because you've heard me, but, but there are really very big issues about personal freedom at stake. And my question to you is, so what would you do in this circumstance? And I think at that point, I haven't answered the question about an ethical base. I told you it was going to be entirely practical. I hope you'll forgive me for that. It's not academic in that sense. But these are real issues today that need real answers from the Christian community. Thanks.
Thank you very much indeed. Well, more questions?
Yes. Why can't technology wait for philosophical or open debate?
Have you ever known technology to wait? I think it goes right back to the politicians' dreams that there are the links between investment and economic return.
But we could introduce some legislation that forces people to wait. They don't want to wait.
Would you like to suggest what legislation? Because I can't think of it.
Well, the debate on stem cell research, for example. In America, stem cell research was banned for some time, perhaps it still is. That might be an example of a case in which scientists have to wait for ethical debate.
As I understand it, California spends more on stem cell research than we in Europe. People migrate to where they can do it, and countries break rank.
That's how Cambridge recruits stem cell researchers. Yes, next question. So, yeah.
Thank you. Thank you for quite a vast and interesting presentation. There's one word that I missed, linked to something that is perhaps of concern to us here. The word that I miss is communication. What's the role of communication in this whole area of decision making? And then if you talk about do we trust the lead, who do we trust to do the lead decisions, politicians? Well, from the Eurobarometer we know that politicians are the least trusted to the public in that sense. So what do you feel is the role of scientists in this whole area?
Yeah, well, that's one reason I wanted to raise it, because I think actually we tend to bury our head in the sand a little bit if we look at our own little area. That's what I wanted to raise the debate about, because I actually think there is almost a need for, dare I say, the United Nations view on this from scientists that can come together, because actually scientists do work well together. We have big arguments, but in the end we tend to be able to work together. And that's why I mentioned I think there is actually a need for something like a Geneva Convention on some of these issues where we can actually meet and have the debate. Now there are some fora around. There's the Global Science Forum, for instance, of OECD. It tends to be a bit of a talking shop, to be honest, and it's not at the right level. There is also various other meetings that go on. But I really think this is something where heads of state have really got to take it forward, and that's what I'm preparing a paper for the G8 meeting in June with the Commission, and really we're asking the heads of state to give a mandate to a certain group of people to start to look at these issues. But I think first of all you need to be informed about what's going on, And what I tried to do, and I know it was a whistle-stop tour, and I told us when you're sitting in the airport, you don't have time to think about the consequences of what you're saying necessarily. But you know, it is a big, very big issue, and you need some of the finest minds and some of the finest ethical minds to start to really address this.
Yes.
You haven't related this to the military, and of course one of the huge issues that we face, whether we're people of faith or people of no faith, is the extent to which the speed of these developments are actually going to be picked up primarily and in the first instance by the military. So I think that the question of communication is a critical one in terms of scientists saying what might be possible with these sorts of technologies. The thing I suppose I was missing in your presentation is the link between what is now becoming possible and how that might be used. And that seems to me to be the public issue that ought to be brought out. But of course we know from all the investment in science, although you mentioned the 3.9 billion in 2010, that's nothing compared with military investment. And presumably a lot of these technologies are accessible to people who are primarily concerned with developing the war instruments.
Yeah, actually, I'm sorry, I had meant to mention that, but it's going to be my sort of terms of reference at the beginning to say I wasn't going to talk about military because it was another big area, and I wasn't going to talk about biology either, medicine, because again it's an area I didn't know about. But the slide I flicked up, which was the one on hyper, the big lasers, I was visiting the National Ignition Facility in Lawrence Livermore just last week, and that is 85% military. You can guess why. And the big debate we're having on hyper is whether that is a civilian facility or civilian plus military. And I shouldn't say this really, but I've just signed a deal with the Atomic Weapons Establishment in Aldermaston to work together with them. And I questioned myself whether I should do this. This is my role as at Imperial, to work on shock physics. And you say to yourself, do I really want to do this? What's the linkage? And then at the end of the day you say, well, actually, maybe one can be a force for good within that. And it's a debate that you can have whichever way you do it. I mean, you can see the upside and the downside of it. But you are right, a lot of this is driven by defence. Certainly a lot of the computational stuff is driven by defence. On the other hand, what I'm finding is that I had been to Portland Down in my last job, and now with AWE. What you find is that the people in those establishments are very bright, but they are totally not linked in the communication chain with anybody else. And so my reason for signing the deal was to put that communication chain in so one could have an informed debate. But it's a very difficult area. Yeah, very difficult. I still remember the first talk I heard on Star Wars where the chap was talking about the number of mega deaths that were statistically possible. I just felt revolted. I just wanted to walk out of the room. But I stood in there simply because I thought, well, actually if I walk away, then other people would start taking this over. But I like your reflections because I don't actually really know how to deal with it. It's a fact of life. It's not that easy to resolve. Do you have any thoughts? It's an old trick, isn't it, to throw the question back at the question.
Do you want to get the mic to...
But I think my question is really triggered by what you said at the end about the extent to which scientists could come together, possibly functioning through a United Nations body to... I mean, it has shades of hogwash, and the implications of addressing some of the issues that are obviously developing at a very fast pace and which are not generally recognized. UNESCO, I suppose, is another body that might be thought of in this context, but I suspect what you're saying is that we probably do need quite a different international body which focuses on the issues that have to do with public interest and the interface with military in a completely new way. which is something that Pugwash, of course, has always been concerned with, but is so focused on nuclear that it doesn't actually embrace the area that you've been discussing. So I think it's a very interesting, very important point you make, and I wonder whether you've raised it with the Royal Society.
Well, to some extent, I mean, my main link is to Academy of Engineering, but just going back to that, Marburger, the Secretary of State for Energy in Washington, says UNESCO, I will not deal in any way with the United Nations. So that knocks America out straight away. If you look at Carnegie, which is a lower level activity, you find that countries like India and China and Australia are not involved. And I really do think it does need a body. The trouble is UN is Americanized, discredited. So you do run into problems. I mean, one of the things, I haven't got time to go through what I'm proposing to the G8, but actually is to use high-level ambassadors, rather like we use John Patton at the European Research Council, somebody who's had a political career but isn't now influenced by it, who can actually bring these things together in some way, a sort of almost international ombudsman type of role that could bring people together. But I'm quite happy to have that debate. But you are right that we do need to raise these things at a much higher level within the scientific community as well as the...
I mean, there is another body, of course, which you haven't mentioned, and that is the Inter-Academic Council, which consists of the 15 leading academies in the world, which do meet to address specifically this sort of issue. There are potential bodies that one could think of, I think.
Yes, well, that'd be useful to know. I didn't know about that.
Okay, I think we're going to have to start after 2, and we do try and start at 2 o'clock. But I've been enormously stimulated by this insight into the huge problems there are as well. And I think we want to thank John very much indeed for opening our eyes to that. So thank you.